So earlier we talked about the benefits or the pros of the completable futures framework. Let's now talk about some of the cons, the downsides. And once again, we're going to use the comparison of the completable futures framework with the Java parallel streams framework to compare and contrast these two different approaches to things and look at some of the downsides. So it's arguably the case that programming with parallel streams is easier than completable futures. So if you take a look here, on the left-hand side, we see the parallel streams version. On the right-hand side, we see the completable futures version. So, why is it easier? And so one reason, well, first let's just start with a little bit of a discussion of the similarities, the commonality between these things. Both of these approaches have a similar control flow. So you can see they both start out by turning a list of something into a stream of something. Then we get rid of the stuff that's been cached. We then download stuff. Then we apply the filters. Then we go ahead and collect the results, and we're done. So at that level, at the high level, they're similar control flow. And one of the nice things about streams, again, you can see here, is that it's pretty easy to see that the control flow is fairly similar, whereas if we had loops and if statements, it might be a little harder because it would be buried in the details of those control constructs, which are just more verbose than the nice streams fluent interface model. However, the use of async behaviors are more complicated than the sync behaviors. So we've got async behaviors here on the right, and we've got the sync behaviors on the left, and they're more complicated. And so you should think about what makes them more complicated. And we'll talk about that in a little bit. There's therefore a trade-off between performance and programmer productivity when choosing between these two frameworks. This is true of many, many things of computing. This is sort of the age-old, one of the common trade-offs in computing over the past 50 or 60 years. I'm sure you've heard of time-space trade-offs before. That's one type of trade-off. Sometimes algorithms work more efficiently, but they use more space. Sometimes algorithms take less space, but they work less efficiently. That's one type of trade-off. The type of trade-off we're talking about here is between computing performance and programmer productivity. And so one of the nice things that generally happens with these higher-level frameworks is they do a pretty good job of striking a balance between computer performance on one hand and programmer productivity on the other. However, it's not perfect. And so what you'll find here is that completable futures are typically faster, they're more efficient, they're more scalable, as we see with these performance results, but they are a bit harder to program because of some fundamental issues there having to do with the way in which the computations run asynchronously. At the heart of this, of course, is the fact that most people have spent the bulk of their time as developers using synchronous communication. So synchronous patterns of programming are pretty well understood. Synchronous being request, block, wait for the response comes back, continue on your merry way. Request, response, two-way, synchronous calls. That's what parallel streams gives you. And in contrast, completable futures don't do that. They have this asynchronous flow, and that's just not quite as well understood. And there's a nice article that sort of talks about this and some of the issues and so on. Conversely, parallel streams are easier to program, so the productivity side is given emphasis, but they're also less efficient and less scalable. So you have to think about that in terms of a trade-off between these two different properties. And one thing that's nice about parallel streams, that's really nice about parallel streams, is you can typically start off with a sequential program using sequential streams, get it working, get the right results, and then convert it to a parallel stream, and then you're trivially running in parallel. And that, most of the time, just requires minuscule little changes going from stream to parallel stream. So that's a win. That's on the ledger side of easier to program, but as we saw, possibly not as efficient. As usual, it's essential to know the best practices and the patterns to program any of these things efficiently, but completable futures in particular. You have to sort of think about the way in which things chain together, and you can use completion stage methods, and when to use the arbitrary arity stuff, and how to wrap it with those collector frameworks we looked at which will give you sort of the best of both worlds where you get good performance and good productivity. So that's the end of the overview of evaluating the cons of the Java Completable Futures framework.